Okay, welcome back to the channel. Ha 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 ha. Um, all right. Okay, so I haven't done one of these in a while, but I have some questions, and I intend to answer these questions. So, the questions I got asked about was from the chapter 3 of the stage 1 mathematics book in relation to domain and range, the first topic, and some questions about sine diagrams, which I'll go through. Okay, so I can go through all of these ones here. So I was asked to do these ones involving the graph. And I'm not going to do all of the sine diagrams, but I will do 3 of them. All right. And if you get the general idea, you'll be able to see how to do the rest. All right. So starting off, let's have a look at these graphs. So as you can see, we've got a whole bunch of different graphs, and we basically have to find the domain, which is the boundaries of the x range, so how far left, how far right it goes, and the range, how far up and down it goes. Okay, I also happen to copy out some of my favorite symbols that I can't get easily, so that's going to help us a bit. All right, so first of all, okay, so let's go through some of these. Why don't I just copy you out so I've got some space? Domain and range. Okay, whoopsies. Select tool, move you over here. All right, that should be enough space. And I'm just going to copy you over a few times. We'll just do domain and range, fill you up. Okay, so now when you think about domain, well, I should probably prep this part as well. When you think about domain, think about the most extreme left value and the most extreme right value. And if anything's moving, anything's missing in the middle. If there's any vertical asymptotes, if there's any points that are not otherwise part of that. So we have mostly continuous functions in here with a few asymptotes. So it's no step functions, no raw data. There's a fair bit. So these are nice kind of graphs. These are mostly graphs that you can put in your graphics calculator. So, all right, domain and range, domain and range. All right, and domain and range. Okay, one more. Okay, so starting with the first one, we have a linear line which terminates at the top left point of -1, 3 inclusive. So that's a filled in dot there, you can see. So that point is included. So when we say that, we could, this is a good opportunity to copy out this, because X does include, oops, okay, issues here. I don't know what you're beeping about. All right, I'm gonna move my setup a little bit closer to me. I might increase my volume as well. All right, so let's have another try of that. Okay, there we go. Why is the mouse? Why are you being a silly mouse? Okay, what's going on here? All right. Oh, yeah, it does a little bit. Okay, so now the point of 1, 3 is included. So sorry, I should say -1. Yep, so that's the one I want. Okay, so X I'm being a bit clumsy today. Oh, let's just do it this way. X and -1. Okay, so we've got that. And then all we have to do is copy out our inequality. Move that to there. I want to move it, not shrink it. It won't let me. All right, we're going to do zoom. That's a bit better. Okay, so I might have to flow back and forth. It's just going to make controlling this a bit better for the sake of the video. All right, so I was going to do this with just writing it out, and I thought, okay, no, let's make it a little bit more formal. Unfortunately, I'm just having technical issues. Okay, there we go. First one. All right, now, y goes down by 3. So let's write that out. Indices y is less than or equals to 3. So in this space, 3. Okay, and that's less than or equals to. Let's get my selection tool. Oops. Oops, so use a need more space. You need to move across, and you can fit in there. There we go. All right. There we go. Okay, there's your domain and range. All right, the second one is also linear, but it has a it has boundaries on the left and the right. And top and bottom, and it has points. The point of the left, the lowest left, is actually not included. So when I write that out, I'll start with something like this. Okay, domain is x is actually blah 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 blah. Okay, the -1 is not included. That's easier on the right. So -1 is not included. So that's the wrong side. And this one is included. So I'm put the 5, and we'll copy out that symbol. Okay, I'll get used to it eventually. All right. We can do a similar thing for the y. So the lowest point is 1, and the highest point is 3. 1 is not included. 3 is included. All right, let's do that. All right. So 1 y. Okay. 3. All right. Now I'm not sure I'm gonna do all of these because I just know this video is gonna labor on. It's kind of repetitive. So at least take a few of these. But I always can come back to this document. I'll save it, I'll upload it, and I'll repeat it, all of it. I just don't want this to allow video to go for half an hour because people get bored. All right, so there we go. That is, so the point of 3 is included in the, no, hang on. I wrote the wrong number. I was thinking, that's right. How, the range. Okay, that is the same, isn't it? Okay, 2 different functions, and they both have the highest point of 3. I got confused there for a minute. Okay, no, and it is included. All right, so that's the first one. Second one. Actually, one symbol I forgot to get. Let's go search for it, shall we? All right. Okay, now I could just do a strike through. I think I know what you might be thinking about that. All right. So, away any secrets? All right. There we go. Okay. That's something else. All right. All right. So let's have a look at does not equal. All right. There we are. We want that one. Okay. That one's going to be very useful. So we'll do a few of these, but let's go back to our paint. Okay, so I'm going to paste that. I'm going to put a Word document. I'll make that size 14, and boom, there you go. All right, so we've got that in our little simple set. That's going to be useful for the next one. Part C. All right. Now, when it comes to functions with asymptotes, it's kind of useful to mention what you don't include rather than what you do include, because you can see this arrow points all the way right, that arrow points all the way left, that points all the way down, that points all the way up. There's only one value for x and one value for y that is not included. Okay, so we're going to use the not included sign by the strike through. Okay, so we can say x. Why did you go to start dancing? Look at dancing. That's a dancing x. What's it dancing? All right. A couple of bits. It looks a bit like I don't know. I don't know what to say. Okay. Times. Let's go back to basics. That's what I want. Okay, that's my curly x. Need the curliest of x's. All right. So we want x and we want 2. I don't need to go that far. All right. All right. So x does not include 2, implying that it includes everything else. All right. So next one will be the range. Now we have a horizontal asymptote of y equals -1. That's the only value that's not included in y. So y -1. Okay. Does not include. So we won't include it. How about that? We won't include you. All right. Just have to copy you out. And there we go. Okay. Picking up the pace here. All right. So let's have a look at something that's a little bit more continuous. All right. Okay. Yeah, let's do D. I'll do D, and then I might pick one of the later ones. All right. So D. Let's have a look at here. Now notice the arrow points all the way to the left, goes up to 0. The 0 you do not need to mention because it is an included point. Then it goes down like that. That is an example of a bell curve. All right. Now, it makes an asymptote on both sides, horizontal asymptote with y equals 0. And the highest point is 2. So, now, because it has no missing points for x, we can say that, all right, we got this. All right. That's going to be a very common thing. We might as well just I don't want to copy you, I want to move you. There we go. X is included in the set of real numbers, so all values are included. When it comes to y, we write it in inequality. It's because there's a range of values. It cannot be 0 and 0. So we say, okay, it's not italics now. 0 is great. It's less than x, which is less than that. Oh, lost my answer accuracy. I'll copy another one out. Okay. 2. Let's give it a bit of space. Okay. So I might have grabbed that one by accident. Okay. You can go. I'll copy you there. I don't want to change the size. I want to move you. Okay. I have to make it bigger. All right. I have to make it enough that I can actually get enough of that so I actually can move it places. All right. So I'm putting you in there. I realized this is what I did. I put an X instead of a Y. You're probably all screaming, "It's a Y, sir! It's a Y!" Yeah. Why? Why? You all love to say why. Okay. I can't put it on top. Swap you out. Mr. X, you do not belong in the range. Okay. Why? You belong, Mr. Y. There you go. Okay, that's correct. Now, see, it doesn't touch y equals 0, but it does touch y equals 2. Okay, I'm just going to talk through the couple of more of these. We can talk through them. Domain x in the set of reals or values. Range y is greater than or equal to -1. For f, x is included in the set of reals. Y is less than or equals to 6/4. Sorry, 6 and a fourth. Would be 6/4. Okay, that is the lowest point. The highest point is infinity. That's the leftmost point. The right point is infinity. These local maxes and mins are redundant. They are not necessary because that goes higher and further to the right than both of them. So the domain is all points of x greater than or equal to -4. The range is all points in x, all points in y, I did it again, all points in y greater than or equal to -3. Done. All right. The domain for this one, all points of x. X is including the set of reals. The range is y is greater than -2. And for I, the domain is, let's do that one. X is not equal to -2. I'll just put a comma. X not equal to. All right. And then the range is a little bit different. All right, let's go find my, okay, I'll put you down. Let's go find my, that one. No, don't want to do that. I want select all. Yeah, I'll put you there at least. Phenomenon, yeah, squeeze you in. Okay. So there, x cannot be -2, x cannot be 2. All right, the range is y is less than or equals to -1 and y is greater than 0. All right. Put a bit more space, I had trouble with that before. And y is greater than 0. Okay. Okay, there's that one. All right, so I'm not going to write the rest of them out because that's time consuming. So I talked through some of them. We can always add more later. So I've only picked 3 of these ones. So we're now going to sine diagrams. And I haven't drawn my axes. Let's do that. I actually do I have the option of doing arrows? Can I do arrows on both sides? No. I'm not going to bother. Just do lines. Okay. 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 All right. And while we're at it, let's just copy these out. Okay, so I've actually put a little bit of notes there. Why don't we actually just draw arrows on the end? That's continuous. Okay, that's a bit rough, but it will do for now. Okay, and then we can just go copy, paste, and paste again for you. Okay, so we've got D, H, and L. So these are right response. Okay, now in question 3, these are what we call rational functions, in that you have a fraction of a function on top of another function. Okay, now the key interest points is when the numerator is 0 and the denominator is 0. They have very different consequences. If the numerator is 0, you end up with x-intercept because y equals 0. All right. If the denominator equals 0, you have a problem. That's called a vertical asymptote because it's undefined. You can't divide by 0. You end up approaching infinity. Now, we treat those differently. So for an x-intercept, we draw a single dash, and we'll draw a dotted dash for the other ones. So for that, I should say, for the first one. Okay, if the numerator was equal to 0, x 4x minus 1 would equal 0. If we rearrange that, x equals 1/4. Now, if the denominator equals 0, x equals 2. Now, the problem with that is, no, it's not a problem. All right. Okay, so we have 1/4. That's going to be our solid line. And 2, which would be a little dash line. I'll make it more. Close enough. All right, so that is 1/4. And that is 2. Now, all you're going to do is substitute easy values in the middle of these 3 domains and to work out the sign. So for example, I want to be to the left of 1/4. I can substitute 0. 4 times 0 is 0, minus 1. Well, that would be negative on the top. 2 minus 0 is positive 2. Negative divided by positive is a negative. You can check with your numbers and see for yourself. I have put these graphs up, and I'll show you those in a moment. All right, so next point, between 1/4 and 2 would be the point of 1. You would have 4 times 1 is 4, minus 1 is 3. And then 2 minus 1 is 1. That's 3, so that's positive. Okay, last point, put the value of 3 for this part. 12 take 1 is 11. 2 take 1 is negative 1. So positive divided by negative is negative. There's your signs. Let's do the next one. So you've got the x-intercept is 0. More the point, I'll say x cannot equal 2. Is the other way to look at it. And then x cannot equal minus 1. So you might want to label them as x-intercept and vertical asymptote, but for the sake of brevity and making this short video, I'm not going to do that right now. All right, so we've got 0 and dot, 1 Okay. Notice this is a squared factor. Basically, oops, I realized what I did. Made a mistake. Yes, it's x plus 1 squared equals 0. That would actually be a minus 1. So I might tidy that up a little bit. Let's get rid of you. All right. So x cannot be negative 1. All right, so it's actually negative 1 and 0. That's better. Okay. So, all right. Okay, well, let's do it. Now, on the denominator there is a squared value. A squared value, basically, if you end up with a bracket negative, so x plus 1 for values of x would be negative if x is on the left-hand side of minus 1. However, because we've got a square, you times that by itself, 2 negatives multiply to make a positive, and 2 positive also make a positive. So what happens around here is there is actually no sign change. It will be the same sign on those two sides. We'll prove it in a minute. That is a linear factor, so it will change. Okay, so let's start with the right-hand side. I'm going to pick 1. 1 is positive, so positive on top, 4 times 1. And then 1 plus 1 is 2 squared, that's positive as well. Positive divided by positive is positive. Okay, if you are the left is 0. Okay, if I had something like minus a half, 4 times minus a half would be minus 2. Minus a half, so yeah, sorry, I should say minus 2 on top. And on the bottom would be, actually, you can pretty much say everything on the bottom is squared because it is positive because it's a square. It has to be positive. So that's negative because the negative divided by something that's always positive. Now, if you pass negative 1, you're also negative because of the same reason. Okay, so I had minus 2. That top would be minus 8. That's always positive. Minus divided by positive is negative. So my negative divided by positive is still a negative. Okay, last one. X-intercept is x 3 minus x equals 0. X would be equal to 3. And we have two values that it can't have. X cannot be 2 from that null from this. So using the null factor rule. And it cannot be, if you rearrange that, 2x plus 3 equals 0. Rearrange that, move the minus 3 across, divide by 2. It cannot be 3 on 2. So that's a bit wonky. All right. All right, that's meant to be a dotted line. So we have two asymptotes that are linear factors. So that one is a minus 3 on 2. Next one is 2. And then we have 3. All right. All right, substituting values into there. So 3 on 2, I can do minus 2. That would be positive on the top. Minus 2 here will be negative. Minus 2 for minus 4 plus 3. Yeah, there's 3 negatives. Negative times negative on the bottom will be positive times divided from a negative on the top is also, sorry, that's positive. That's positive and negative times negative. So that is positive. Okay. All right. Okay. Easiest point would be 0. So 3 divided by 3 times negative 2. So the negative on the bottom, positive on the top, that's negative. Okay, between 2 and 3, 2.5, that would be positive there. 2.5 times 2 is 5, plus 3 is positive, so positive and positive. And that's also positive. So positive. These are all linear factors, so you kind of know they will change as well. That's another kind of given, but we're proving it as we go. And the final one is, so I take something like 4. That would be negative on the top. that would be positive here and positive there. Negative divided by two positives is still a negative. So that's how you do those sine diagrams. So, all right, I'm going to leave the video there, and I'm going to upload this and leave it there. Okay. Oops, let's not do that much. Not delete all our work. All right, I'm going to wrap up the video there. Catch you guys next time.